Hello and welcome. I am in a very unusual position today, which is that for the first time in literally months, I feel like I'm sort of caught up. Like I still have an enormous backlog of things from earlier in the year, but uh, oops, I think I accidentally inserted a robot command at the same time as I was hitting record there. Anyway, um, yeah, I've finally caught up on that crazy weekend of like 12 local chapter cases on the 10 cases that came out from the MEWC knockouts. And so now I'm going to do something that feels vaguely indulgent, which is play a new game that just came out yesterday. This is called Excel Coin by Tim Froelich. And I haven't read this yet, but he did describe it a little bit when he shared it. So let's see. Welcome to new case concept. Here's a gift for you. Two lambdas to add to your collection. Encode text takes a text input and encodes it using base64 encryption. Decode text decodes it using base64 encryption. Hash text takes a text input and hashes it to a near unique 8 to 10 number long sequence. The below levels will walk you through using these lambdas as well as introduce you to the world of blockchain and cryptocurrency. By the end, you'll be a pro at mining Excel coin. Value not guaranteed. Love it. All right, yeah, let's dive on in. We'll come back to the bonuses at the end. Breaking down encode. Using the encode pre-built lambda function, encode the given strings. This might be the easiest example in Excel esports history. Encode. Just follow the above instructions in example 1 and use your encrypt lambda to solve these super easy 20 games. Love it. Okay, decode. I think I might have got the idea. Let's see, does it take an array? No. Congratulations, you have learned how to use both encode and decode. Now it is time for 4 more harder levels. Okay. Hashing it up. Now, a fundamental concept of cryptography as a whole is proof of work. In order for a block to be trusted and prevent spam bots, you have to prove you did the work to propose encryptions. Fun fact, this concept is how some junk folders work in email. First step of proof of work will be generating our unique hash. This time you need to use the hash text function. Using the encoded given string, concatenate with the nonce, number used only once, at the end. How many trailing zeros are there at the end of the hashed string? Okay, so we encode the string and then concatenate the number used only once. That says 85 blah blah blah, but this, okay, fine. Then if you hash it, it returns this, in which there are 2 trailing zeros. Okay, so first we need to hash of encode, keep doing end encode this and this, and that sure enough has two trailing zeros. Then I want, what do I want? I guess I want, this is just digits, so we could do text after sequence 9 minus 1, and then take the len of that. Oops. Wow, you're telling me all these numbers actually mean something, so I'm learning the basics. Love it. Did you really do that? Now it's our turn to act as the verification police and make sure other cryptographers are doing their job. We have the following dataset given on the right of the 2025 round of 16 scores by player that people are trying to submit to the blockchain. It's important that data going in is as we expect, and the block proposed wasn't just a spam bot. Join the scores with the dashes between player and the score and the semicolon between player score sets. It should look like Dear with Early 720 Lorenzo Fodi 992. Thanks for picking that one as your example, Tim. Our Excel coin will operate under the assumption that you need 3 trailing zeros at the end of a hash for it to be genuine. In the real world, cryptocurrencies are much more secure. Bitcoin is currently at 19 leading zeros for a block to have sufficient proof of work. For the given nonce, our miners say they used in proposing their block. Is the block valid? Answer yes or no. Okay, so are we encoding the whole set of scores? I'm not totally sure what we're doing here. I guess we are. So first let's text join all of this on our delimiters are a dash first and then a semicolon. Close that. Oops, sorry. Text join, that is not how text join works. First the delimiters, then that. Okay. So that gives me that. Oh, wait, what? I'm only supposed to be using this data set? Ah, okay. Is that the same? I guess not. Okay. Fine. So then point it to this. Glad I spotted that. All right, so then we're going to we encode it first and then add the nonce, right? Yes, and then hash it. Okay. So we're going to encode that, then add the nonce, then hash it. And sure enough, that ends in 3 zeros. So then I just wanted to say if right of this by 3 equals 0, 0, 0, then yes. This is all caps, otherwise no. Nope. Also calc errors. What? Oh, because I didn't lock. Stupid. We're encoding the same message every time. Okay, that's better. Level 5, medium hard. Chain, chain, chain. Now it's time to use the concept of valid blocks from our last level to build our blockchain. Blocks proposed on the blockchain use the fundamental concept of a chain, hence blockchain. You need to include the last chain's hash for the current block to be valid as well. The format for a proposed block on the XLCoin chain is as follows. Hash of previous hash dash hash of encoded current block of transaction data timestamp nonce. Assume the initial block is 10 zeros. Okay. Given the block being built off, along with the nonce that makes it a valid block and the data on the scores tab, return the valid block. Each block will use just 1 round's worth of data following the same formatting as level 4. Good. Okay. So previous block of this, the nonce of this, the only round that returns a valid block is round 0. Uh-huh. Each block will use just one round's worth of data following the same formatting as level 4. What? Okay. So we've got a bunch of zeros. Then we've got encoded version of that. Okay, so first things first. What I'm not sure about is what round are we supposed to be using? Are we supposed to go through the rounds? Yeah, there are 20 rounds plus 0, so I guess that's the intention. I'm just going to add round 0. I guess I'll take the formatting, be nice. And then sequence 20. Okay. And then I guess I'll do brev. Oops, brev. And this can be rept 010. And then this is just going to be this, I guess. And this will be this, and carry on down. Okay. So now we want to hash this previous one, and I guess I can just text join these, can't I? Okay, so text join with that, and the things we're joining are first this, second encode of text join with a dash and a semicolon, filter this where this equals where is it? I216. That's the text join, that's the encode. Nope, missing a closing bracket somewhere. Oh yeah, the filter. The text join, the encode. Okay. Then the third text is xlookup I216 in here, returning the timestamp. And the fourth text is nonce, which is H216. If this works first time, I'll feel very good about things. Okay, and then we gotta hash all of that. Wait, hang on. That does not look like... Yeah, this is supposed to look like 2,4. This doesn't look anything like that. What on earth have I done? Let's go back to the level 4 logic. How was I doing this? Yeah, so I encode it like that, add the nonce, and then hash it. Okay. Alright, so let's just take this piece out for a second. I guess guess let's take the encode off for a second. And that gives a bunch of people, sure. Oh, sorry. Hash of encoded current block. Fine, good. Okay, so then I need to wrap this encode in hash. That looks better. And then we hash all of that. And we get that. Hooray. And then let's see if I've locked things right. Oh dear, bad start. Bother. Okay. So I have the previous hash. Yes. I have timestamp, which is 45680. Yes, 680 for this round. Yes. Then I have nonce. Yes. Bother. The question is, so I'm returning the chain. Let me see, is this not supposed to be joining them together? No, I'm just supposed to have a totally different looking number. Oh, wait, hang on. Maybe I'm not supposed to use round 1. So what if I look for a round that'll match this? There we go. Okay, fine. So I had the wrong idea about the round. Okay, so then I want to map sequence 21, all of this stuff, and lambda RND for round, and that's the round I'm going to take, and the timestamp is also going to come from that round. And that should give me a bunch of stuff. And then I want to find the one that ends in, oh dear, that's a calc error. Sequence 21 starting at 0. And then I want to find the one that ends with 000. So I guess I can xlookup. Let's let TMP test be all that stuff. Then I want to filter test where mod test by 1000 equals 0. Okay. That's a bit harder work, but it gets there eventually. And does it now carry down? Whew. It's a bit of work. I don't know what's going to happen to the quality of my video recording if this keeps up, but never mind. So, okay, we can get rid of the round, and we can get rid of all this, and we're good. Okay. Wow, that is calc intense. All right, one more level to go. Okay, I thought I would record a new ending here because I was accidentally working off an older version of this case, which meant that my level 6 went wrong, and that because it's cumulative, a whole load of it went wrong, and I just spent a whole bunch of time doing stuff that isn't very interesting, and then also the bonuses, I just misinterpreted a bunch of things. So I don't think I was really doing justice to the case, so I'm going to make a clean run. I'm going to start with the bonuses because level 6 is very calc intense. So you wrote down your hashed password that consists of 2 uppercase letters followed by 2 digits, but forgot the actual password. If you wrote down the hashed this, what is your password? Okay, so for this, we're going to have to construct all the passwords. And I guess I should mention I have some handy-dandy constants for the uppercase letters. I actually have one for nums as well, I think, although I usually just do sequence of 10, but anyway. So let's first construct all the passwords. Let all PW be, so we're going to start with uppercase letters. and 2 row of uppercase letters. So that'll give us all our possible, let's just take this out. Sorry, I am happy to write formulas just like this. How has that gone down? I thought that was 440. Anyway, whatever, it doesn't matter. I'm happy to write formulas like this because I understand what they look like underneath, but I realize that's hard to view, so I'm going to just visualize it here. So here we've got A to Z going down, A to Z going across, so we've got all the different combinations. We're going to flatten that with 2col and then add a sequence of 10 across starting at 0. So now we've got AA to ZZ followed by 0 to 9 going across, and then we just need to do the same thing again, so 2col all of that. And add this sequence at the end. So now we've got everything from AA0 down to ZZ9, followed by 0 to 9. And then we 2col that one more time, and that's all our possible passwords that are 2 uppercase letters followed by 2 digits. So we'll cut that out of there, bring it back over here. All right, sorry I got pulled away, but I think I had it in the clipboard. So all passwords is this. Then I guess all hash will be map all password hash. That's going to take some calc, and then we'll xlookup. What is it? 23379633265 in all hash, returning from all passwords. Grind, grind, grind. That's going to take a little bit. God, is this so much calculation that I need to pause the recording so you don't have to watch? It's always a risk with this case. It is very calc intense. Okay, I'm starting to think it's a yes. I'm going to pause. Okay, only paused for 15 seconds or so. That's not too bad. Using the same nonce between one. So I think what this means is using each nonce between 1 to 1000 for each of the string inputs of level 3. How many trailing zeros are there in total? So we just take the level 3 formula, and we're going to turn that into map of sequence of 1000, lambda num, all of this stuff, and then just replace this with num, and then we need to sum those. And I guess if we're really feeling fancy, we could then map, oops, not make array, map of all of these, lambda str for string, and then we could just do that. Actually, hang on, we don't have to do, I think encode is probably pretty light, but we don't have to do the encode every time. So let's say lambda str let nstr be encode of string, and then we'll only have to calculate that once. Nstr, okay, and then we want some of those, I think. And again, this is probably one where I need to pause while it calculates. Let's see how long it goes. Okay, only paused for 15 or 20 seconds that time, not so bad. How many valid blocks exist using the first 10,000 numbers as inputs? No encoding necessary. So I think all this means is, I want to know how, so I'm going to map the first 10,000 numbers with hash, and then I want to know how many of those end in 0. So we're going to say end in 30, so I mod that by 1000 equals 0, and then we want sum of minus of all that. Might be another case for a pause. Oh, I need a pause there. That was only like 4 seconds. Okay, what is the average hash value rounded to the nearest integer of the 21 rounds following the same input text formatting of level 4 and 5? This one confused me a bit because the input text formatting in levels 4 and 5 encoded and then hashed, but I think we're only supposed to encode. Okay, so, or sorry, we're only supposed to hash but not encode. So I want round average map sequence 21 starting with 0, lambda num, and then my can I have colors on these brackets, please? Thank you. No, all of them, please. That's better. Okay, so it's going to be hash of text join with a dash and a semicolon, I think. Then we're going to filter the player and score where round is equal to num, and round that to 0 decimal places. Ah, we didn't even need to pause for that one. Almost instantaneous. Okay, and then if you hash the rounds in the order in which they're used in the level 5 answered, return the hash of this. Okay, so for this one, I just need to rejig the way I've done level 5 a little bit, because here I just get out the hash that works, but what I can do is, let's just take this, make it look pretty. So we'll say the hash and the round. And then we'll take this formula, which will give me both, if I ask it nicely. And then instead of just filtering for test, which is the hashes, we'll filter for hstack test and sequence 21 starting at 0. That is taking quite a while for one calculation, but I guess the whole thing's just getting heavy. Anyway, that's good. And then I can point this to that, so that I don't have to calculate it twice. And then this already points, yes, only to things that are within the same row, so that's fine. Copy down to there, and we'll copy this to there. Let it spin for a second. Okay, so these are the rounds in the order in which we use them. So I want to join with that, all of these, and that'll ignore the blank nicely, and then I want to hash that, which shouldn't actually be terribly calc intense at all, but let's just bring it up here to where it belongs. No! What? Oh, sorry, yeah, I think maybe I'm supposed to not include the example. That's better. Okay. I'm just going to make a couple of notes on this because I just highlight that one and that one. That's ones that could probably do with a little clarification. All right, now it gets really calc intense. Let's do level 6. Okay. So we're going to need a bunch more columns for sure. So our actual answer is the guesser, but we also need to know, let's see, we'll need to know the previous one, because I want my formula only to operate within the one row, and that's going to start with rept of 0, 10. Then we need to know the previous timestamp, because that's cumulative. And then we need to know the hash, the guesser. What else am I looking for? The guess number, or the timestamp, I guess. And and the nonce, just to make it easy to check. Okay, and previous timestamp will be 0. Okay, I think it's going to be easier to work with this in a flat format. So I'm going to say guess, minor, and nonce. So the guess, I'll start with just the nonce, is going to be to_call of all this. And then for the rest, I have this handy flatten function, but I'll just show you. So the idea is we can say ifs this, or ifs that, not equal to blank, then I want this, that'll then to_call 3. Oops, I'm missing a closing bracket there. And that'll give me just these 5 repeating over and over again, this exact same size. And then you can do the same thing, replacing the header with this to get the guess number. Oops, what? Oh, sorry, got to replace it in both places, of course. Right, so that's the minor. That's normally I would just do flatten of, and in this case they're all non-zero numbers, so we just say flatten of that and header. And there it is. Except I've put those the wrong way around. Ugh, stupid. No, don't take it into the table, thank you. Okay. So there's my guess, minor, and nonce. So now I need to let the hash be, so, or I guess call it test hashes, will be what? We're going to map. The only part of this I think I'm interested in is the nonce, so we'll just map this block lambda nn for nonce, and then we're going to hash of text join with dashes. Okay, and then the things that we are joining together are the previous hash. Ugh, stupid. Then the hash of encoded current block of transactions slash data, which is just this string input, I think. So that's hash of G 265. Then the third thing is the timestamp, which is, so we need to map on that and the guess number, plus the previous timestamp, which is I 265. So then it's going to be lambda of nonce and timestamp. So then the third piece of text we join is the timestamp, and then the fourth piece is the nonce. Okay, so that's the test hashes, and then we want to filter each stack test hashes. Test hash. Why is that not auto-completing? Something is not right here. Let's just do that. Is it happy? No. Because the brackets are mismatched. Okay. So we got to close the hash and close the lambda and close the map. Okay. Now we're looking better. Now we'll filter of hstack test hashes. Now it autocompletes good with all of these things, guess, minor, and nonce. Yeah, that's fine. Where mod test hashes by 1000 equals 0. And we're interested in the first person to make the guess, so we're just going to take one row from this. That is going to calculate for quite a while, even though that's only one step. Oh dear, gave a calc error. Oops, that's not good. Why? Short answer is probably because I bugged it up, but it's the previous hash, the hash of the hash of encoded current block. Okay, try again. So we should get this hash 3914472000, and we should get guess 230. There we go. Now we're looking good. Okay, so then the answer is just going to be that. Then the previous is going to be that for that one, and then for all the rest, it's just the row immediately above, and the previous timestamp is going to be this plus that, and then again this plus that, and copy down. The answer, we can copy across, copy down even. They're all wrong, that's okay, that's because I haven't put this in yet, and now here comes the calc intense part. We're going to copy this, I'm going to paste it in all of those, and then it is going to calculate, and I'm going to pause because that's probably going to take a little while. I'll be back. Okay, it worked! Woo! I think that was like 3 or 4 minutes of calc time. I don't know, I went off and did something else and only just noticed that it finished. But, okay, so is that everything? I think that's everything. Yes, that's everything. Hooray! That was a fun case. Thank you, Tim. I'm not sure I've learned quite as much about the blockchain as I might have if I'd really, thought more about applying this. But I did enjoy these things. Easier than pipe mayor. Aren't you glad it's not cards? Yes, I am. Good luck in Vegas, everyone, and so on. Yeah, there's a lot of good banter in this case. I'm curious. Tim mentioned that there was a level 7 he was contemplating, but didn't end up writing. Maybe that's because it would have required an entire data center to run. But I enjoyed that case. That's all I got for today. Thanks for watching. See you next time.